conditional probabilities. It's sometimes called Bayes' law. Actually, Bayes' law is a more generic version of what I'm going to show you today. If you look at the handout that I just gave you, on the very back of it, is there a blank half page? Can you turn to that, please? What I want to do to start out with is to do just a generic any tree, two-level tree. So I'm going to draw a tree that looks like this. A, not A, B, not B, B, not B. What I want to talk about is the numbers, the values, the weightings that we put on these branches. We would call this right here the probability of A occurring. We would call this the probability of A not occurring. Alex, we would call this number here the probability of B occurring given that A has occurred. This is the probability of B not occurring given that A has occurred. This is about what I call this one, the probability of B occurring given what? A hasn't occurred. And this is the probability of B doesn't occur given that A doesn't occur. There's my generic tree in notation. And the reason I'm doing the notation, Justin, is today's lesson, I don't know of an easy way to do it. I have to fall back on the equation. In fact, as a matter of fact, you might even want to get your formula sheet out, or you might want to open your workbook to the inside cover, whichever is easier. Wherever that formula is. Is it the inside front cover, Mitzi, where the formula page is? Yep. Okay. I'm going to put some numbers on here. I don't want you to put the numbers on here because I want this tree to remain generic, Ryan. But for what it's worth, if we said something like A was getting a king and B was getting a king, then your numbers would be 4 out of 52, 48 out of 51, 3 out of 51, 48 out of 51, because now there's the 3 kings left in the deck. Here you didn't get a king, so you'd say this was 4 out of 51 and 47 out of 51. Yeah. Thank you. I would have double checked because I would have made sure they added to 1 and that one didn't. Okay. So if I said to you, what's the probability of a second king given that the first king has occurred, you would say 3 out of 51. What's the probability of not getting a second king given that you know that you already got a king? 4 out of 51. 48 out of 51. Here's what we're going to ask. Instead of going down the tree, today we're going to go up the tree. Today what I'm going to do is I'm going to give you this part of the tree and I'm going to say, all right, suppose you know the second card is a king. And that's all you know. What are the odds that the first one was a king? We're going to go backwards up the tree. We call that conditional probability. Given that the second card is a king, what's the first card? And you'll be able to tell to use today's lesson when you're doing a tree because you'll say, oh, they've told me the bottom level occurred and they're asking me about the top level. I'm going backwards up the tree. As opposed to previous questions where it's just work my way down. Okay. Go back to the front of the lesson. So example 1. A pot is randomly selected. There's the 2 pots to pick from. And then a bill is randomly chosen from that pot. So Brett, there are 2 events. We're going to pick a pot, pick a bill. All right, let's do a tree and then let's answer the questions. I would do a probability tree. First of all, we got to pick a pot. Let's say pot 1 or pot 2. What are the odds of picking pot 1? Meant to be really obvious. 1 out of 2. 1 out of 2. Then inside pot 1, it looks like you can get a 0, a 10, or a 20. Same with inside pot 2, you can get a 0, a 10, or a 20. Given that you're in pot 1, what are the odds of getting a 0, Dominique? 1 out of 3. What about a 10? 1 out of 3. What about a 20? 1 out of 3. Dominique, given that you're in pot 2, what are the odds of getting a 0? 1 out of 4. 10, 2 out of 4, 20, 1 out of 4. There's my tree. Now let's answer the questions. A, part 1. What's the probability that a $10 bill is chosen if it's known that pot 1 is a selected pot? What this is saying is, given that you know your pot 1, what's the probability that it's a $10 bill? That's a number that I can lift right from the tree. This is not an and question. It's not saying what's the probability that you got pot 1 followed by and a $10 bill. It's saying, hey, I already told you you got pot 1. Don't worry about it. If you're in pot 1, what's the odds of getting a 10? What did you tell me? 1 out of 3. The second question, if you're in pot 2, given that you're in pot 2, what's the probability that you got a $10 bill? So that's going to be a 10 given 2, and I can read that right from the tree. Dominique, 2 out of 4. Or I could simply say to you, hey, what are the odds of you getting a 10? Eric, do I know which pot it is this time in part 3? Have they told me specific? Then I have to look at both possibilities, pot 1 or pot 2. Eric, what does or mean? In fact, this is where I'm going to say this. 1 and a 10, or 2 and a 10. This is where I'm going to say to myself, it could be this branch or this branch. This is where I'm going to say to myself, multiply all the way down now and add my way across. It's going to end up being 1 out of 2, 1 out of 3, or 1 out of 2, 2 out of 4. Do I have a built-in common denominator this time? Well, it's going to be over 6 and over 8. I'm going to be supremely lazy. I'm actually just going to go like this. 1 out of 2 times 1 out of 3, or 1 out of 2 times 2 out of 4. Enter, math, enter, enter. And I've got my lowest terms. Yeah, it is 12s, 5 12ths. The odds of getting a $10 bill, 5 and 12. By the way, if you found the odds of getting a 0, and then you took the complement, that would tell you the odds of winning a prize. Today we're interested in D. Kara, can you read D to me? Stop. Another word for if, draw a little arrow. Given that. They'll say given that, or they'll say if, or they'll say suppose that. Keep reading, start over. What have they told me? What do I know? The second row. The bottom row. What are they asking me to find? Going up the tree. You see how you can recognize it kind of visually? Now, the way to solve this is to translate it into a conditional probability statement. Probability that given that it's a $10 bill, so given that it's a 10, find that you came from pot 1. And you can see, I hope, Dominique, it's the opposite of this. 1 given 10, not 10 given 1. How do I solve this? This is the only time I fall back on the equation. You do have a conditional probability equation on your formula sheet. Sandali, can you read it to me? It says this, the probability of, spot it there, yeah? Find the thing that's got a little vertical bar in it. I have no idea what you're saying. Got a ladder. Probability. Let's use probability instead of P. No, not A and B. What's that vertical bar mean? Right, you're looking for this, kiddo. Find that. Okay, so That vertical bar does not mean and. What have we said that vertical bar means, folks? Given. Okay, so you ready? What does it say, Sandalee? Keep reading now, loud. Is equal to what? Divided by? The problem with this equation is sometimes you'll have a B there and an A there. Sometimes you'll have an A there and a B. It's confusing. So here's what I remember. This is how I'm going to remember it. You can't write this down on your formula sheet, but you can figure it out from your formula sheet. I remember this being the probability of both and divided by the one that they gave me, the given one. I remember that equation as, I identify it as a conditional. How? I'm going up the tree, and then I say, oh, that's going to be the probability of both of the events that they're telling me divided by the one that they gave me, the given one. If I translate this previous line up here, this is going to end up being the probability of 1 and 10 divided by the probability of a $10 bill. Some people call this Bayes' law. This is a subcase of Bayes' law. And I can get all of this from my tree, 1 and 10. What does and mean, Trevor? So can you read to me down the branch that has a 1 and a 10? What numbers will I put here? What times what? 1/2, 1/3. Trevor, what does it say on the bottom, my friend? 2 branches end in a 10. 1/2, 1/3, or 1/2, 1/4. Most of the time when you set up a conditional probability statement, Sandalee, the number on the top will appear somewhere in the bottom. 2/4. Sorry, 2/4, Mr. Dueck, 2/4. Thank you, Sabina. And Sandalee was the one that caught that, I think, asking you first. 2/4. Sandalee, do you notice, though, both of these appear right there? That will usually happen. Can I cancel? Have I factored? Is it factored? No, don't you dare cancel. Let's keep going. The top I can do in my head. Top times top, bottom times bottom. I think it's going to be 1/6, yes? The bottom, conveniently, don't I already have that right here? If not, I would go to my calculator or do the arithmetic, but it's sitting right there. How do I divide by a fraction, Spence? If you know that a $10 bill was chosen, the odds that it came from pot 1 are 12 out of 30, or divide by 6, 2 out of 5. The odds that it came from pot B are 3 out of 5. Conditional probability. It's the probability of both and divided by the given one. When do you use it, Joel? Because you notice you're going up the tree. I like example 2, I like example 2, I like example 2. Example 2 is a nice question. A company has 2 factories that make computer chips. Suppose 70% of the chips come from factory 1 and 30% come from factory 2. In factory 1, 25% of the chips are defective. In factory 2, 10% of the chips are defective. A says, find the probability that chip is defective, and B says, suppose a defective chip, given that a defective chip is discovered, what's probably that came from factory? You know what? Let's do a tree. First, we have to pick a factory. How about 1 and 2? Then, in factory 1, it can be defective, not defective, defective, not defective. Caitlin, what are the odds that we came from factory 1? As a decimal, please. 0.7. What are the odds that we came from factory 2, Caitlin? 0.3. By the way, I didn't need to tell you that, even though they told you 30. I would expect you could clue in. Well, 70% come from factory 1, 30% must come from factory 2. If we're given that we're in factory 1, Caitlin, what's the probability that we're defective? 0.25. What about that it works? 0.75. What about if we're in factory 2? Well, it doesn't make as many, so I guess maybe they have better quality control. What are the odds that they're defective? 0.1, which means 0.9 or not. Justin, what's A asking me to find? What it's asking me to find is not D given factory 1 or factory 2, because it says I don't know which factory, so it's just saying what's the probability it's defective. And I think that's going to be that branch or that branch. Those are the two that end in defective. Here we'll give our answer as a decimal, since they gave me stuff as decimals. It's going to be, again, Maria, multiply down, add across. Oh. Come here. 0.7, 0.75, 0.7, Mr. Dueck. 0.25 or 0.3, 0.1. If you go into a store and you buy these people's product, what are the odds that it's a defective chip? .205? .205. Joel, can you read B to me, please? Stop. Above here, can you write, given that, there's our trigger word. Start again, read to me. Stop. We need to translate this. What do we know? What's the given? What have they told me? Sorry, I can't hear you. No, what have they told me? What's the given? What's the suppose? What have they told me? No. Read to me. Start over. Start over. Read. Stop. What have they told me? What's the given? Do you see discovered anywhere? What events are we talking about here? What have they told me, folks? It's defective. Not discovered, defective. That's the event. Much like Brett's alarm clock. Defective. What do they want me to find, Kara? I've translated it now. If you can't write that statement, you can't use the equation. You're going to get 0 out of 4. This is the written question, one of the written questions on your final and on your probability test, a conditional probability question. How do I translate this? What I said, Emily, is this is going to be the probability of both and divided by the probability of the given one. That's what that equation on your formula sheet means. Okay. Emily, which branch has both and? What times what? Did you say 0.7 times 0.25? Which branches end in a D? See them both? In fact, it's going to be 0.7 times 0.25 plus 0.3 times 0.1. Again, Justin, you notice what appears on the top does appear somewhere in the denominator. And I have a shortcut a little bit here because, Eric, we already figured out the bottom. But I would have no problem skipping part A and just going straight to part B and saying, here's the question, in which case you would have to crunch the numbers on the bottom. I already know the bottom is 0.205. What's the top going to be? 0.7 times 0.25, 0.175. Final answer, If I know that the chip is defective, what are the odds that it came from factory 1? That divided by 0.205. Do you get 0.8537? So it was this mathematical modeling, being able to go backwards up the supply chain, that a mathematician in the 1950s proposed to the American motor companies, and they were not interested. So he took his talents to Japan. And the reason Japanese cars were, and frequently still are, better made than North American cars is not that they were made better in the factory. He gave them better mathematical methods of being able to track where the mistakes came from and fire people, or fix the errors on the assembly line. Changed the whole economy. Example 3. A card is drawn from a shuffle deck of 52 cards and not replaced. Then a second card is drawn. Spencer, what is A asking me to find? Depends. What does it depend on? Okay, so you know what? For our tree, let's go, how about King 1, not King 1, King 2, not King 2, King 2, not King 2. Depends on whether that first card is a king or not. By the way, I would even be fussy. It doesn't depend on what the first card is. It depends on whether the first card was a king or not. Anything else, I don't care. All right. Fill in the tree yourself. I'll do it myself. See if we get the same thing. Is that okay, Tyler? What's A asking me to find? Second card is a king. Does it mention anything about the first level, what it has to be? Oh, well then both branches are feasible. This branch or that branch. 4 out of 52, 3 out of 51, or 48 out of 52, 4 out of 51. And I'll go straight to calculator lowest terms because I'm in a rush. 4 out of 52, 3 out of 51. You can get 2 kings, or no king on the first, still a king on the second. You get 1 out of 13? Anybody else want to double check me? Yeah? Probability the second card is a king, 1 in 13. Sorry, can you read B to me? Ooh, given, that's my trigger word. Maybe this is a conditional. I don't know. Keep going, keep going. Ooh, they've told me something happened on the second level. What do they want me to find? I'm going up the tree. This is a job for conditional probability. I got to translate it into a statement, though. Let's see. This is going to be the probability. Asar, what's the given thing? What do I know? What did they tell me occurred? King 2. What do they want me to find? Not King 1. Which is going to be both of them. Not King 1 and King 2, divided by the given one, King 2. Which branch has not King 1 and King 2? Oh, this guy. Boom, boom. 48 out of 52. 4 out of 51. Over. Which branch is king 2? Oh, both of those. Oh, which conveniently I already have here, don't I? I'll rewrite the numbers just so you can see what we would have done. It's 4 out of 52, 3 out of 51, or 48 out of 51, 48 out of 52, 4 out of 51. But that's really 1 over 13. What's the top work out to? (16 over 221). How do I divide by a fraction, Spence? Or I can get really lazy. I can go to my calculator. If I put the entire top fraction in brackets, divided by, and I've got to put the entire bottom fraction in brackets, otherwise it won't know that I'm dividing by a complete fraction. (16 out of 17). If you have a king, where's my deck of cards? Right there. If I pick one card, don't know what it is, and I pick a second card, and that second card ends up being a king, there's a 16 and 17 chance that this is not a king. Is it? Be a good bet to take. Might have been. 1 in 17 chance that it might have been. I grabbed that first card randomly, even though I looked for that second card. C. Is C still talking about kings, Kara? No, face cards. You know what? I need a new tree. I'm going to draw mine down here in the corner because I need more room. What would be a good letter for face card? F? Oh, sure. So how about F1? Not F1, because the second card drawn being a face card depends. What does it depend on? Whether the first card was a face card or not. F2. Not F2. F2. Not F2. Kara, what is a face card? Because you looked a little puzzled there. How many face cards are there in the deck grand total? It is 12. Did you use the fundamental counting principle to figure it out by going 3 face cards times 4 suits is 12? Good. 12 out of 52. 40 out of 52. Down this branch I picked a face card, so now it's 11 out of 51. 40 out of 51. Down this branch I didn't get a face card, so there's 12 out of 51. 39 out of 51. Answer C and D on your own. Let's see if we get the same thing. I'll freeze the screen. Am I right? Yeah, someone else got something? Yeah? No? Trevor, thumbs up? Yeah. Give a bit more time. And then maybe we'll save your life. Okay, conditional probability, how do you recognize it? There's a bit of a trigger word given, suppose that, if, but you'll notice, oh, they're telling me what happened on the last row, and they're asking me what are the odds of the previous row. You're going up the tree, Maria. Then the only fallback I know is this formula, but I've tried to simplify it by saying, you know what, carefully write the statement, given what you know, what are you trying to find, both over the given one. You all still do you have a bit more room over here on your half page? Let's do a question together. I like this question. I like this question. I like this question. Suppose there is a terrible disease called loweritis that infects 1% of the population. The test for loweritis is 98% accurate. Given that you test positive, what is the probability that you actually have the disease? Now, I'm doing this a bit humorously with loweritis. Replace it with cancer or HIV or something terrible. Sadly, much of the public, and sadly, Brett, many doctors would say, oh, if the test is 98% accurate and you test positive, there's a 98% chance that you have the disease. And what's horrible is some people, after receiving this news, take their life. They commit suicide rather than wait for the disease to run its course. And what they don't realize is actually there's a very good chance you don't have the disease. You see, Trevor, this is a conditional probability statement. Let's go like this. How about event D, you have the disease. How about event P, test positive. Let's do a tree. You have to have the disease before you test positive or negative, so we're going to do disease first. Here's our tree. Disease, not disease. What percent of the population has the disease? 0.01, 1%. So what percent does not? 0.99. Then you can test positive or not. Positive or not. Alex, down this branch you have the disease. So should you test positive or negative? You should test positive. How often? How accurate is the test? And that means 2% of the time it'll miss it. Call that a false negative. No test is perfect. Down this branch, Maria, you don't have the disease. So should you test positive or negative? If you don't have the negative, how often? How accurate is the test? 0.98. goes on the negative, and 2% of the time, Maria, you'll get a false positive. Maria, my dear, can you read to me from the word given in the question? Stop. Okay, sorry, keep going. Given. Stop. Given that I'm positive. Keep reading. See the statement? That's how I'll translate it, Maria. Which is going to be D and P divided by any branch that ends in a P. Which branch is D and P? 0.01, 0.98. Which branch is, oh, two branches end in a P? 0.01, 0.98, or 0.99, 0.02. Trevor, there's two terms in the denominator. Make sure you use brackets around the bottom. Crunch the numbers and get a surprising answer. What'd you get? Sorry? What? 33? No. This test is 98% accurate, and you tested positive. That must mean you have it. Anybody else get 33? You mean the odds are you don't have it? What? Give it to me to 4 decimals, please, Brett. You got a better chance of not having it, even though you've tested positive. And so, Kara, the message I have for all of you, if you're ever faced with bad medical news, get a second test. Now, if you double this tree and add 2 more levels and you test positive twice in a row, then the odds go up to about 90%. Then you probably do have it. Or, Joel, if you're listening to the news and you hear of an athlete or a celebrity testing positive for drugs, wait till you hear the second test results. Any of you going into the law or the legal system? Yeah. Suppose there's a lie detector test that's 98% positive, and there's only 1% of people that will lie when they're on the lie detector test. If someone fails the lie detector test, what are the odds that they are actually lying? Only 33%. This is why you can't use lie detectors in the court of law. Can't. A little more depressing. Suppose 1% of the population is racist and only 2% of the population is a minority. Given that you're a minority, what are the odds that you'll encounter racism? Sorry. Even though barely anyone is racist. Sorry. Conditional probability, very counterintuitive answers. What bothers me is I read a paper. A number of doctors don't know this, and so they're advising their patients that they are going to die of cancer. Probably not. Almost certainly not. In fact, I'd take those odds any day. Those are pretty good odds. I'd like better odds still, but if that's all my choice, I'll take that. Can you be so kind, please, as to go to your book and open to page I think I'm going to skip the examples here, although they are nice, and I'm going to go straight to lesson 6. Can you turn to page 466? This is Bayes' law. This is the longer, more complicated version. If you're doing multiple events, we're only going to be looking at 2 events for conditional probability, a 2-level tree. But if you want to extend it, that's what it looks like. So the one that you can use on your formula sheet is, where is it there? Well, it's on your formula sheet. I showed it to you. I like example 1. I like example 1. In fact, I'll tell you, your conditional probability question on your test and on your final exam, it's going to be one of 3. It's going to be the factory defective question. It's going to be the disease, not disease question. Or it's going to be this one here. Let's read this one here. Urn or jar A contains 4 black balls and 2 white balls. Jar B contains 4 black balls and 6 white balls. An urn is selected at random and a ball is drawn from that urn. So the first thing, select a jar. Second thing, select a ball. If the ball is black, what's the probability that came from urn A? I think they're telling me the second thing and they're wanting to know what are the odds of the first thing. This is a job for a tree and it's going to be conditional probability. So let's do our tree first. Jar A, jar B. Brett, what are the odds of getting jar A? Keep it simple. 1 out of 2, 1 out of 2. Now, if I want to make this question a bit more interesting, Brett, what I could do is maybe have you pick a card or roll a dice to change the odds to help you decide which jar you're going to pick. Then we can have, now, problem, I was going to use W for white and B for black, but I've already used B here for a jar, and I don't want to get confused, so I'm going to go with white and not white. White and not white. Is that okay? Eric, how many white are there in jar 1? In jar A? Out of? How many black? Out of? Eric, how many whites are there in jar B? Out of? And then 4 out of 10. Now that I've got my tree, I could ask you all sorts of stuff. I could say, hey, what are the odds of getting a white? Or what are the odds of getting a black? But that's all this question asked. This question said, if given that you didn't get a white, what's the probability that it came from? Which one, Sabina? A. And I'm going to write that as the probability of A and not white divided by the probability of not white. Good, try this one on your own. I'll do it up here. Let's see if we end up with the same thing. I did that wrong. Oh. Is that right? I find these answers very counterintuitive. Ellen, what's the answer? 5 out of what? There is no 8 anywhere in that question that I see coming to my mind anywhere. I always find these counterintuitive. Or the one we did earlier that ended up being out of 17. There was no 17 that I saw anywhere showing up in that question. So these are nice, they're counterintuitive, and certainly I hope that disease one was like, wow, really counterintuitive. What's your homework? Here's what I gave the last class. I assigned some from page... I think I assigned some from here, Mr. Dueck, didn't I? Come on. Go. Page 460. Turn to page 460. Number 1. Page 460, number 1. Number 4. And then from lesson 6, page 468, number 1. 4, 5, and 8A and C.